All right, thanks, Andy, and welcome everyone. I saw that a lot of you that signed up have, been in some Simcenter Femap sessions before, so hopefully this won't be too much repeat. I'm going to go over quite a few topics, but again, some of these only have a couple of slides, so don't worry, I'm not going to PowerPoint you to death. All right, so just a little bit about the feedback roadmap. I mean, we're not really going to cover anything outside of the versions that you see here. Just know that the current version of Femap is 2506, which was released in June, and then there's already been one maintenance pack for it that was released in August. So, that's just where we're going. And then, of course, the next version will be 2512, which will come around the end of the year. So the first thing we're going to talk about today is managed environments. When we're talking about that here at Siemens, we're talking about Teamcenter Integration. So what does this allow a Femap to do? It allows, Femap files and the related files to be managed by Teamcenter in our Teamcenter share environments. These are controlled, and everything that we're going to do with it are on the PDM menu, which we added in 2301. So just a little bit about the history of what we did in 2301. Initial implementation also allowed us to deal with what we called the shattered JT assembly. That was kind of a big thing because we really had no way to read in those before. But we were very limited because new items had to be created via the rich application client before you could use them in Femap. 2306 just allowed you to specify a server. 2401 a little bit, just got all the commands up to date with the proper names. But then in 2406, we added various enhancements. This was updating the dialog boxes with column filtering, just made them look an entirely different way. Added the ability to create a new item when saving the Teamcenter, which was big. Ability to open modfem and neutral files, and check in and check out functionality. For 2412, just got this a little bit going a little bit more. Added the ability to import geometry directly from Teamcenter or the analysis model or analysis results. We can basically save all those same things back to Teamcenter. And one of the neat things that we have that a lot of people may not have seen is this add associated files. So you can include things that are in the same directory, say Excel spreadsheets, PowerPoints. But the big thing here would be including the results files from, say, Nastran with the model file for a particular analysis set. So that's just all stuff that can be automatically added. So now we're up to 2506, and this is the big thing here is it allows the creation of the CAE 3D analysis item. You can make that from within Femap. You can also specify some CAE target relations with the source CAD. And this was just really for better integration with Teamcenter Sim, and then just a little bit of searching help. Again, if you haven't used Femap since 2301 for some reason, we finally added a command finder. Again, it was an initial implementation. Then we started allowing you to look in keywords. Search for keywords or look in toolboxes and panes. 2401 was the big kind of leap forward, gave it just an entirely different look and feel. It now lists all the matches dynamically while you're typing. It'll then highlight these areas in the product, whether they're in the menu toolbox or a toolbar. When you hover over it, there's actually a hyperlink to search online for your query. And it also supports, searching, again, toolbars and the custom user tools. And then just a little shortcut key that we added up there at the top. By the way, I'm going to go through the presentation and then I'll be doing some demoing at the end. So just some, like one of these simple things, a lot of times you might need to find all the holes of the same size, just so you could use something like geometry surface remove hole or use a tool in the Meshing Toolbox to help you get rid of holes that you don't want. This is just a nice way where you can pick one, it'll find all the rest of them, and then it'll just get, it'll just select them all for you. Some other things specifically involving groups, just because we know how important groups are to everybody, pretty much using Femap. The condense used to turn everything into ID rules, but what it did was it would condense everything down to ID rules, but even if IDs of a particular entity type didn't exist, they would still be in the rules. so that probably was not the best thing. So we actually now condense it down to just the IDs that exist in the model. But then probably a better thing that you might want to do is use this newer group operations reduced to existing command. It basically did the same thing as condense, but instead of taking everything down to ID rules, it basically kept each rule around in the group. So it actually allowed you to keep the same functionality and original intent of the group, but it shrunk it down to just what existed. There was a known issue in it, again, that was actually fixed in that that maintenance pack I mentioned that came out in August. So if you are having some trouble with that, just know it's been fixed. And then just a little bit about automatic add. If you renumbered, what we were doing was kind of adding it twice. So more of a bug fix than an enhancement, but just something to talk about. 2306, we changed how we access all of our CAD data translators. So now we're using the same components as a lot of the rest of the products at Siemens. So what did this get us? It got us a new CATIA V6 translator, an Inventor translator, and a Rhino translator. And if you'd ever been paying for the CATIA V5 translator before, it's now part of the base product. Again, it's just trying to make it easier for us because these are I shouldn't say us anymore for Femap development, because these components are very well maintained, and it's just an easier way for Femap to keep the CAD geometry up to date. And if you were accessing geometry through the API at all, it's now all done through the geometry interface object. Again, just some nice stuff that we did in the Meshing Toolbox, because everything, it's better when things are interactive. One of these things was we have Femap points and we have Parasolid points. So if you ever make just individual points or individual curves in Femap, that's actually making stuff in Femap's standard geometry engine. So it's non-Parasolid geometry. So a lot of this didn't work from the Meshing Toolbox, but now it does. So again, if you have wireframe models that have a lot of Femap curves and you want to do some updating like this, basically if you have this geometry, pick those points to move, everything updates, everything shifts as needed. So then basically, you can do the points to move as well. So you can actually do it in 2 steps, that type of thing. Another one here, every once in a while you have a fillet or something of that nature where you just want to, say, replace that with a plane instead of a fillet. This is a little hard to explain, so I'm just going to go on the next slide where you can actually kind of see what's going on. So you can see, kind of have that opposite type of fillet, going from thin to thicker. So what we allow you to do is just basically put in a plane. We fit Femap fits a surface to it. Then the modified geometry just no longer has it fillet. Might be a little bit easier to deal with. Big one for 2406 was edge replace. Essentially, what you can do is this basically allows you to pick one curve and then match it to a second selected curve. And it depends on the method. The nice part about this is it works with surfaces, solids, and/or the general bodies, or the general bodies again are things that have been non-manifold added together. And you have 3 options here. You have full, partial, and edge aligned. Again, it's just probably easier to kind of show it here. So basically, on it just going from left to right, top to bottom. If we have the original geometry, if you pick that first curve and the second curve, depending on the method that you have selected, you're going to get 3 different outcomes. So you can see on the left, basically, it's just taking the original, the first curve you select and replacing it with the second and updating the surface as needed. Partial is just moving the points, and edge aligned just projects the points kind of along the curves that were part of the first surface that you select. Now you can see if you pick these in the opposite order, you actually get some quite different results. And even when you use partial, that's actually working as expected, just because, again, it is just doing a closest normal projection. So something to think about, but super handy if you're doing anything with mid-surface models. And again, this all works, and a lot of effort was put in to make sure it works with non-manifold added geometry, so it's not breaking any of those connections. Something brand new for 2506, again, probably something would be great for the shipbuilders, but also, folks making airframes. Is we added this, we added some options to project curve just to make life easier. Just this kind of combines a bunch of steps. There's now two options for picking which surface you want to project onto. You can still just use a single one, or you can do any number of surfaces with the add surfaces section. Then there's the big one here, which is transfer attributes. So as you project these curves down onto these surfaces, basically it's going to take those meshing attributes and it's going to transfer them and reposition them if needed on here. And I believe you'll kind of see what's going on here on these next slides. The meshing attributes that are super good to try to use here are the ones automatically created by the geometry curve centerline command. And I'll demo this a little bit later. So essentially you can see it here. You have this original geometry. You make the center lines. Then when you project them down, the actual position of the mesh attributes has not changed per se with respect to the model, but is now projected. It's now basically down there on the bottom, so it aligns with the surface. So essentially, you can kind of see from over here, you can see that this was going down the center line, but now it's basically just moved those curves and projected them. And along with projecting them, it's also split it, so then you can see the resulting mesh that you can get. Little bit about Z-Aero, a little bit of a video that you can watch kind of to see what flutter behavior is. So ZONA is this company that was founded in 1985, happens to be the same year Femap was founded. It's very focused on aeroelasticity, highly specialized field, kind of focusing on the interaction between the structures and aerodynamic forces. They worked with MSC Nastran in the 70s, and into the 90s, just adding things into Nastran. Their big product is called Z-Aero, and you'll kind of see why that's important. And what we're really going to focus on is what we did with them in terms of flutter. And just so everybody knows, why is this important? Because Siemens acquired ZONA in March of last year. So the process prior to 2506 was rather manual. You were really dealing in a text file world a lot of the time. In order to get things to run, it certainly worked, and because it can do hypersonics and supersonic work, it's very interesting, especially in a lot of today's applications. So what can you do now in 2506? You can handle the structural model and the aeroelastic model all in one. Now, obviously, we supported the Nastran aeroelasticity for quite some time now. So we had to kind of decide which way we were going to do this. So instead of it just being the model aeroelasticity, you do have to choose whether you're doing Nastran aeroelasticity or ZONA aeroelasticity. So if you're in the ZONA world, what we're talking about is these things: the C-Aero 7, the PA foil 7, body 7 spline, and A chord. Again, everything can either be created via model ZONA aeroelasticity or through the aero model in the tree. Just know that if you are trying to make Z-Aero items, you're going to want to use the new Z-Aero ones instead of the Nastran ones. So, and again, I'm not going to get really into this. Just we support the C-Aero 7, the full dialog box, the PA foil 7. This is kind of Excel type data, and you can also do a preview of a 2D plot of of the section data just to make sure that you have it your airfoil looking correct. You can dynamically display the panels with aero thicknesses. With all aero models, you have to spline it. You have to spline the aero entities back to the structural model, so you can make a spline, have all the options in there. The body 7, this is very important if you are going to be using this at all, is that we support read and write. of the body 7 and graphical display, but there are currently no creation methods in Femap to do this. So you have to manually create it in in one of the other ZONA products and then import that body 7 entry into Femap. Laminate enhancements, again, if you've seen a Femap presentation of what's new rather lately, you know that we added this in 2401, and what this does is it actually is just a great way to automatically build layups. So again, I'm not going to go crazy with this. Essentially, you have three choices. You can either make a new layup stack, you can load a layup stack from layups, or you can attach a composites HDF5 file, which in this case is always still just a file from Fibersim, which is another Siemens DI product. So once you have these layup stacks, there's a number of things that you can do with them. But the big thing is that you either use the entity, you need to use the entity selection over here on the right-hand side. And what this allows you to do is pick elements, surfaces where you get the elements on there, or groups of elements. And you can kind of combine these all together. And then once you go through there, it uses these options for layup creation and composites HDF5. It uses these to determine how it's going to go about automatically creating your layups for you. And just one thing to add about, in case you didn't know, is he added randomized property colors and the ability to set an offset bottom surface option in 2406. Yeah, I'm not going to really get into this. Yeah, you can move them up and down. You can check for errors. You can clear the whole thing. But once you have this all specified, there's just the ability to show the selected elements, outline the selected elements, show the apply fiber direction, really tried to give you as much feedback as possible to know that you're in the right place. You can basically pick an element and it'll show you which rows are going to be used for that particular element. So that lets you know if you have it properly, that element is properly going to have the right layup on there when it's created. Then you also have some options in here, whether you want to show the whole component, outline the component, or show the apply fiber direction. Now, this is typically used when you do have this Fibersim file that I mentioned. And again, I'm gonna do a quick demo of this at the end. And then we just have some additional items here. When you're using the composites HDF5 file, the nice part is there's a button that you can click where it's just going to use information from the HDF file to automatically determine which elements should be selected by each row. So that makes it even easier. Unfortunately, you don't have that information just when you make a apply stack up, but it does exist in the HDF5 file. And you can just do show previews and mesh info as well, just to make sure that you can. And again, there is that command down at the bottom, which is check layups versus composites HDF5, but that's more of a spot checking piece of functionality than anything else. And depending on whether you're doing new layup stack or composite HDF5, you get different columns that show up. And there's also, when you're talking about using something like the global plies, there's ways to automatically make a bunch of global plies for you, so you don't have to do that all the time. You don't have to assign each one automatically. One of the last things here is when you're doing the entity selection, again, you select elements, select surfaces, or select groups for each row in the layup builder. And then there's also this errors column, which can appear where if you go over a particular red field in the errors column, it'll actually explain to you what the problem is for a particular row, like you have an invalid thickness or an invalid material. Now, along with this, what we added was this command, which might have even been, just as important, which was model laminates add plies to mesh. So what this will do is it just allows you to add apply, something we call apply material, which was new for when we added the new layup manager, or an actual layup. And you can put it top, bottom, above a global ply, below a global ply. You can assign them failure theories if you want for solution 401, 402. And again, depending on what you have selected, in ply type, you get different options on the right-hand side of the dialog that allow you to do this. So why is this important? So let's just say we have this. And here we had 3 layups and properties and corresponding properties. If I just wanted to add, say, apply, or 2, 3, another 2, 3 ply layup or something of that nature, just to this section of elements, essentially I can just come in here and use this command. And what it will do is I'll go from having 3 properties and layups to having 6 layups and properties, and it'll just automatically do that for you by just adding what you specified. Not going to get super into this, but we do now support rotor dynamics with Simcenter Nastran. This is solution 414. Just uses Nastran input. You can use it as a tokenable solution. It offers it's easy to learn, easy to use, that type of thing. So in order to do this, we had to add a number of things. So we had to add 3 new element property types: bearing gear and Fourier transfer, rotor dynamics entity types, so XY plot definitions, some bearing speeds and rotational speeds, and 2 new load types: unbalanced mass and unbalanced moment. And there's a ton of other dialog boxes and things in here that maybe I'll go over a little bit later. For 2406, just something people had asked for is we were always just taking our rods and turning them into RBE2s, which was was really not great for people trying to round trip. So we added full support for the R rod, basically through the dialog box we used to make the other types of rigid elements, and same thing with the R bar, so that we now support both of those in 2406. Another good little item here for 2406 was we always had the ability, like after you imported a Nastran model or a model really from anywhere, we had the ability to auto create load definitions. So we just basically did the same thing for auto create constraint definitions. And what we're talking about is it's going to take all the constraints that have the same degrees of freedom, nodal output coordinate system, and non-zero value if you have one specified. It's going to take all those and put them together. Why is that important? Because then it allows you to do bulk updates of those type of things. Another thing we did was add support for the incompressible fluid surface. So we always had support for the virtual fluid, which was an M fluid before, but now we actually have support for this incompressible fluid surface. There's a couple of options that you can specify here for it. What's it really for, though, is essentially it's so you can determine your sloshing modes. So what you typically have is a structure full of plate elements, then you have the fluid, which is made of solid elements, and then you specify the fluid-free region, the fluid-free surface, which you do via this region. So basically putting that on top of the, excuse me, essentially specifying the free surface that you have with one of these regions, then the fluid structure interaction between your fluid solid elements and your structural model happen automatically, and it allows you to get some nice plots at the end of your sloshing behavior. A very simple thing we added for 2406 here was just this option to use existing spacing. Instead of having to know what the biasing was, which side it was, you can just have it just automatically use it. So then as you increase, decrease, set number, whatever, it will basically just keep the original spacing. It'll keep the original biasing. So this is especially good if somebody handed you a model and you did not, you weren't the original creator, so you don't know the biasing, anything like that. Just getting the surface. By now, I hope everybody's heard of our body mesher. It was what we got. It was our mesher that we got from the CD Adapco folks. And so for 2401, it worked fine for surfaces. Sorry, it just did not. It did not honor the growth factor. So if you're using this and you're using the body mesher, now you'll just see that it's going to honor that growth factor in meshing, whether you're using triangles or quadrilaterals. really simple thing. Well, I shouldn't say simple. It's kind of difficult to add, but the mesh region command has been in Femap forever. And I mean, it's probably one of the first 10, 20 commands that was in the product. But if you tried to use it and the numbering wasn't quite right, it could just give you kind of garbage. So basically, if you just were to select the nodes from 5 to 10 there, and then 141 to 171, really in any order, what it's going to do now is it's going to fill in that nicely for you in areas. Now, it's not just simple. You can have it work on something complicated like this with a lot of curvature. Basically, just if it runs over a gap, it's not going to put elements in the middle. But if I were then to basically pick the top and the down the middle, kind of horizontally, what it would then do is fill in those elements there. So by using the command again. A little bit about performance. So again, if you've watched the Femap, what's new lately, you know that we've been working on unified graphics architecture. This is an ongoing program, I should say project. We began development of it in 2301. Once completed, it'll be the only graphics pipeline. So anytime you've ever been annoyed or confused as to why something looks different when you're in performance graphics, best possible, or as to oppose when it's turned off, which we just call, just original OpenGL. All this will be taken care of with the unified graphics architecture. So for 2506, what's supported currently is coordinate systems, all geometric entities, geometric-based loads and constraints, and then nodes, nodal constraints, and nodal and elemental loads. And the one thing that I know is coming for 2512 is beam and solid elements are planned for this. The other thing to know about it is if something's not working as expected, you can always just click on this button in here, Unified Architecture, and you can turn off a particular entity type that you want it to revert to using either, best possible or performance graphics or OpenGL. So if something's not going right, you can always just turn these off one at a time. You just click this button in File Preferences. We added a max frames per second in 2412. Sometimes Femap was drawing something so fast it could appear jittery. This is something you probably don't want to change, but some people have had to do this in order to kind of get rid of the jittering. So, it's just one of those things where if you set it to 40, that's what it's set to by default. But if you set it to 0, that's back to 60, which is actually, again, faster than the human eye can even detect. Something just to know is that you can use the integrated version of the Nastran solver that you can install with Femap. You can actually have that use an enterprise Nastran or token license server. Just kind of a two-step thing. This has been in here for a while, but people always ask. You basically just come into File Preferences, you select the Interfaces tab, and then you specify the license server location in Enterprise License Server. And then once you do that, when you go to Model Analysis, it says it's going to use the integrated solver, and then you just choose, instead of desktop, you choose one enterprise, and then it will use the Enterprise License Server for you. A little bit more about ZONA. Basically we added a new analysis program, Simcenter ZONA, a new analysis type, 39.0. It's starting with Flutter, and then it'll be moving to trim later on. There's also a place to specify it as the link solver. All the aerodynamic data that you need to support it. This was all new for 2506, so just keep that in mind. So, define Mach number, reduce frequencies down at the bottom. Also, just particularly Flutter settings. There's just an entirely other dialog box here where you can just specify everything needed to run your Flutter analysis. So, and if you're, if you're not familiar with ZONA, a lot of this might not look very familiar, but it's just what's needed to run that. Back to those incompressible fluid surfaces. Essentially what you could do, again, in something like this, you could basically just see the sloshing modes. And again, all those are created via that. And then there's actually quite a few options that you can specify in here for a modal analysis or frequency response analysis, including a number of FSI modeling parameters and control parameters, and FSI meaning fluid structure interaction. If you're using solution 401 now, we added support for modal frequency response. So this is one of those things where it's kind of easy to set it up. It's a little different than automatically doing it. You do need to create two subcases, one, a modes, and then one that is sequentially dependent, which is analysis equals mfreq. But all of what is needed to do that is now in the analysis set manager. You can also specify solution frequencies. For some reason, they only added freq 1, freq 2. I don't know what happened to freq 3 and freq 4, but maybe they're coming soon. But again, that was added for 2412. And then just the ability to enter mass and damping information is, again, it's all in there. Not going to harp on rotor dynamics, but again, there are 5 new analysis types. So maneuvers, eigenvalue analysis, complex modal analysis, harmonic response, and transient response. So each one of them is solution 414, but it has like a sub solution. We now support the subspace in the real solution methods. For some reason, Simcenter Nastran didn't have it. And then they updated it for 2406, so you could have from and to hertz, so you could have a frequency range. And then just a little bit, we added support to read-write the Femap layup titles to and from input files for both, for Nastran in general, and the ability to put in 0 stiffness for P bushes. So just a little extra support. Anybody using MSC Nastran, we added the ability to select HDF5 output, and along with selecting it here, you can also, we obviously can now read the HDF5 results from MSC Nastran, and what we're really talking about here is the NH5 RDB format, which was MSC Nastran's kind of newer format for HDF5 files. If anybody's running Abacus, we now we tried to make it look more like other pre and post processors that did Abacus things. So initial step and steps are now in there. You can kind of see how it looked before as opposed to how it looks now. Just know that initial step and step 1 are always going to be created for you if you're making Abacus. And then we also added this option, which is to inherit output requests from the previous step. It was just made everything helpful, made the file look a lot easier, the input file a lot easier. And this is also now imported when you import an Abacus file into Femap, and also the analysis monitor is now supported, so you can monitor your Abacus jobs. Before, Femap would kind of lock as you launched Abacus. Now it's basically, now it works the same way. So the monitor will monitor how Abacus is doing the solve, so you can still use Femap if you want. Kind of a big one here for ANSYS was the ability to read meshed cross sections for beams from ANSYS input files. So we then store them with the appropriate beam properties so they can later be exported. This is kind of a different concept than existed in some other solvers, but we had some ANSYS customers asking for it, and started reading a whole bunch of APDL input that we didn't, and now we support bolt preloads in nonlinear solution sequences for Autodesk Inventor Nastran. Post-processing, obviously we added all the support for ZONA Z-Aero, so now you can look at the structural modal results alongside the Aero results for spline verification. You can display complex flutter mode shapes. Also, this led to this whole idea, which was output tables. So again, just adding the support for ZONA Z-Aero, a lot of this information just comes in tabular format. So as everybody knows who ever read any type of tabular data into Femap from a solver, it was always becoming functions. But what was the problem with that? Essentially, Femap was mixing input data and output data as functions, which was, it was the data was not organized. And then some of the important metadata that was created by the solver was just not being brought in the Femap. So what did we do? So there's better data organization. Now the functions are placed into an analysis study with the other results. You could have hundreds of unrelated functions, because you could have hundreds of these generated by a single analysis. It was hard to, know where they belonged with each other. So now when you delete a study, the output sets and vectors will, get deleted, and the associated output tables. Again, because you couldn't really find them, you had to go identify where they were, and if there was any ID gaps, it could just be a real pain in the neck to do this. Also, the data format, it was functions required XY pair format. So, there was just some things coming from the solver that just couldn't fit in there. Yeah, I'm just gonna pass on that one. So what do we have here? Like new entity type is this, which is output tables. It's associated with analysis studies. It's flexible data handling, so you can have different data structures and data types. You can have paired data in a lot of different ways. You can have vectors and matrices that can come in, integers, floating point values, strings, complex data, etc. And then just a lot of that metadata that was not that was being lost before is now coming into Femap. And so you can kind of see this is where they live and how they look essentially. So there's the output, there's the particular output table type for each subcase then, and then the actual data series information is under there. And you can kind of see the ones on the left were from error elasticity. The ones on the right here are just kind of the modal effective mass fraction tables. So again, the advantages, they're smart. The table recognizes what kind of information it has in it. There's intelligent processing, and then there's various post-processing options. Again, because it knows the data, like you can see the table on the left actually is from ZONA. If we were plotting a Femap function in the middle, it really doesn't know to cut it off after it diverges, whereas the one on the right hand here knows to do that because that's the important portion of the data, because it knows what type of data it's looking at. The charting data also can be copied and pasted over into Excel, and that's just like something that you would see how it comes over. And one of the things that they're really thinking about that the Femap development folks are doing is making bar charts for charting in the future, but we'll have to see if that happens. Again, any type of results from solution 414, I don't know if I mentioned this, but they're all in the SCD5 format. So basically in 2306, Femap had to start reading SCD5 in a particular schema. So again, all solution 414 data is in SCD5. So and hopefully everybody knows that you don't have to expand complex results anymore. You can just have it do it for the view or to do it for the model, and it will do that processing on the fly for your animations. The type of data that also comes back with it, and this is a type of data that you'll find in the output tables is Campbell diagrams. And that's just visualization of the dynamic analysis of the sloshing modes. We'll also now import of arrow box deformations from the Simcenter OP2 file. Before, we were only getting those from the F06. So that's a big thing for Flutter analysis. So yeah, and also for the complex results from Simcenter Nash Transolution 401. So if you were doing a modal frequency response, we added support for those for that data in 2412. Just now, when you rotate the model that has a text object, the leader can go with it, so you can see it like that. And then the last thing here is just a little bit of license management. Kind of changed how we do this. So now you go to help manage licensing. It's just better, gives you a lot more information at the top. It's a green circle and a red filled circle. All right. Let me just go over to Femap just for a second here. And I'm just gonna I just wanted to show you just a few of these things that I talked about. So one of them was, obviously curved center line. I'll just pick any old material. I'm just gonna do it on all of these. And what that did was it actually created me center line and center line and meshing attributes here. So, and one thing I don't know if everybody knows that they can do is they can just highlight over here over the check boxes, and you can say select to hide. Kind of a different way to do this. Instead of having to pick the check boxes, you basically get the standard any selection. So I can just go to previous, just a nice way to turn off all those solids I just used. And then again, if I were to come into this meshing and just go to my geometry editing, this is where I could do my curve project. I could pick multiple surfaces now, pick multiple curves. And again, you can see how the meshing attribute stayed there, but it's been repositioned. So, and again, then I could do it for the rest of these in here. And I'm just gonna skip that for now. So just a little bit about the layup builder. So you can just make a new layup stack. You just give it a title. You can tell it a material. You can give it a thickness, 0.1. But the nice part about this is that, again, you can just pick what's in here. I can select elements if I feel like. Okay, something like that. So then I can see that I have my elements. But I'm just going to clear this for now, and I'm just going to load. It's going to load one that I already have in here. So what this is you can see that I basically have created my whole layup stack. So what do I mean by a layup stack? It's all the plies I might possibly want somewhere in a portion of my model. So once I have this, then I can see that the entity selection has occurred. So if I just want to see where these things would be specified, I can just say I want to come here and pick. Okay, so that's showing an outline. Sorry, I want to do show selected elements. So here, let me pick one of these that doesn't. So in that case, ply 11 here is only going to be put onto those 156 elements in the back. If I want to, I can always check my ply info. I have no errors, great. So then what I can do is I can just say I want to build layups. So, okay, yes, I want to create 3 properties and 3 layups. So I'm just going to say no for a second and just, there's only one property in here right now, and it's just a regular plate property. So I just come in here and say yes. And again, so now all my plies have been created. If I take a look at it. All right, oops, let's just do modify color properties, select all, I'll just do a random one. All right. So, but then again, this is where I can use this new model laminates, add plies to mesh, and I just pick whatever I want. So I just wanted to add 1 ply. I'm not going to add steel, but 0.1, and I can pick where I want to add it. Just going to put in a 0 ply above my global ply of the middle. All right. All right, so then you can see it automatically made me new layups, which now have that new ply that I added into there. So that's very exciting for there. But where this gets super interesting is doing something like using the actual Fibersim data. So I'm just going to get from there. It's just going to kind of give me an outline. So what I can do in here is, which is a little different, I can take a look at, show an outline of the component, show the component, or I can actually do the fiber direction. It's just, you know, just kind of zoom in there so you can just see the fiber direction of each particular ply that's coming from the Fibersim data. I'm just gonna go there. Again, using the data from Fibersim, I can just say I want to automatically do my entity selection. So now I could see what's going to be, like where is that going to be. So I can see that ply right there is only going to be applied to those elements. So now when I hit build layups, it's going to automatically create me 1,179 properties and layups for my 13,011 elements. I'll just say yes, and you can see that it was that. I mean, it was that quick that it did that. If that seemed like a few too many, what I'm going to do is I'm just going to undo. And what I'm going to do is in here, I can actually do some layup creation. So you know what, maybe I only need one every 5 degrees instead of every last, you know, possible degree. So now if I, you know, difference in orientation, oops, sorry, just want to pick my elements again. Yep, check. And then I will build my layups. And here you can see it made me around 700 elements instead. So then I could just say, okay. So that's what the layup builder can do for you. The dynamically updating pointer, again, basically the nice part about this guy is that the text stays in the same place, but the leader updates around with you. So that's kind of the nice thing. And then just a little bit about output tables. Let me just close the layup builder here. And I'm just gonna say I want to do, you can see I have some results in here, but I don't have any output tables yet. So I'm just gonna real quick just run this modal frequency analysis where I've requested some modal participation factors and that type of thing. So now you can see that I have output tables. So they're all just sitting in here nicely. So I can now take a look, and then, you know, I could plot these in the charting window and see what's going on. So again, all that is now just in here. All these output tables just live here. So if I were to delete this, now they all get deleted, you know. So it's just, there's no extra functions that are now living up here, because functions are now really just for input data. Okay. And that's about it. So yeah, let me just go back to the presentation and take it away, Andy.
All right, thanks, Andy. As you guys can see, there's so much information that we're trying to share with you. Obviously, Andy can only go over you know, very high level stuff with some deep dive. But if you have any questions at all regarding Femap, you can come to us and we'll get you the answer. We also provide training as well. So as you can see, these Femap training courses. So there was a question that came in, and I'm going to be able to answer this one, Andy. Believe it or not. So there was a question that came in. Hey, was there any changes to gap element? James Kubley, one of our application engineer, did a whole session on gap element back in March. So that is available on our website. And I just want to take a quick minute to kind of show where you can find that information on our website. just kind of plug our new page that we just put out, because while we put everything on YouTube, some people can't access it. So if you go to our website and go to events on demand learning, you get to this page, and this has a lot of our past events and session. We are continuing to put more information on here, but as you can see, there's a session on mastering gap element in Femap. So visit our website and go to the on-demand page, and you find a lot of the information that you need on there. With that, I think we are running out of time. Like I said, there's a lot of information to share. So thank you for being here with us. Again, if you have any questions at all, you need one-on-one consultation, you need specific questions regarding to your situation or your environment that you don't want to share, on a platform like this, please feel free to reach out to us, and we'll connect with you as soon as possible to help you out. Thank you, Andy, for your time today. Appreciate everybody joining us today, and we'll see you on a future session. Thank you.